Hi viewers, welcome to Learning Electrical Engineering channel. In this video, we will see about maximum power transfer theorem. The maximum power transfer theorem is stating that the maximum amount of power will be delivered to the load whenever the load resistance is equal to source internal resistance. So that point we will prove mathematically here. To prove that, we will consider a Thevenin equivalent circuit which is having a one voltage source and one resistance is connected in series, and we will connect the load resistance across the terminals A and B. Now the amount of current flowing through this load resistor is IL. Now we will see the graph. In this graph, the x-axis is having the load resistance and y-axis is having the power. Now the power delivered to the load resistance is increasing until the load resistance value is equal to the source internal resistance. Thereafter, if the load resistance is increasing, then the power will be started to dropping as we seen in the graph. Now we will see how to calculate the power delivered to the load, and then we will prove the maximum power will be delivered to the load only when source resistance is equal to the load resistance. For that, we first calculate the power delivered to the load. The power delivered to the load resistance, or the power dissipated by the load resistance, P is equal to I square into RL. Now we need to calculate the value of I. So as we know that I is equal to, in this circuit the voltage source is VTH divided by the total resistance in the circuit is RTH plus RL. Now we will apply the value of I into the above equation. So the power delivered by the source to the load will become VTH divided by RTH plus RL whole square into RL. So this is the formula to find out the amount of power delivered to the load by the source, or the amount of power dissipated by the load resistance. Now to find out the maximum power delivering resistance, we will differentiate this equation. Let us say this is equation number 1. We will first differentiate this equation with respect to RL, then we will equate it to 0, because whenever we are equating the differentiation is equal to 0, that point there will not be any slope. That is the maximum point of that particular equation. Now we will differentiate the equation 1 with respect to RL. So the equation will become dP divided by dRL is equal to, in this equation the VTH is constant, so we will take it out, VTH square, and d by dRL of RL divided by RTH plus RL whole square. Now we need to use the U by V formula of a differentiation. So the U by V formula will give VU dash minus UV dash divided by V square. So we will apply this formula into the above equation. So the equation will become dP divided by dRL is equal to VTH square into the numerator term is RL and denominator term is RTH plus RL whole square. So the denominator term we will write first as it is, RTH plus RL whole square, and the numerator term is RL. When we are differentiating with RL, it will become 1, so we will write as it is 1, minus the numerator term we should write as it is. So numerator term is RL and the denominator term we must be differentiate. So when we differentiating the denominator term, so 2 into RTH plus RL into the value of RTH is constant, and when we differentiating the RL with respect to DRL, then it will become 1, so we will left as it is, and divided by the denominator term is RTH plus RL whole square. So denominator term of whole square will be RTH plus RL whole square to the power of 2 will become 4. Now to further simplifying this equation, the equation will become VTH square into, we will take out one term, that is RTH plus RL into RTH plus RL minus 2RL divided by RTH plus RL to the power of 4. Now the RTH plus RL from the numerator and denominator will be get cancelled out. When it get cancelled out, the power will be reduced by 1 because the numerator RTH plus RL is only 1. Now we need to equate it to 0 to find the maximum point. As we know that dp by dp divided by drl gives the slope. So when we are equating the slope equal to 0, we will get the maximum point. So that we will apply dp by drl is equal to 0 to find maximum value. To find max value, when we are equating dp by drl equal to 0, we will find the what is the maximum resistance value when it receiving the maximum power. So we will equate it to 0, VTH square divided by RTH plus RL whole to the power of 3 into RTH plus RL minus 2RL is equal to 0. Now when we simplifying this, we will get RTH is equal to RL. So the load will receive the maximum power when the load resistance is equal to source internal resistance. Now at this stage, the power delivered or the power dissipated by the load is equal to P is equal to VTH square divided by 2RL, because here RTH is equal to RL, so the equation will become 2 into RL whole square into RL, and on further simplification this equation will become VTH square divided by 4RL. So this is the power when RL is equal to RTH. In case if load resistance is not equal to the source internal resistance, that time we need to calculate the power using the formula VTH divided by RTH plus RL whole square into RL, that is equation 1. So this is the power delivered by the source to the load when RL is equal to RTH. Now we will verify the maximum power transfer theorem using a Excel sheet. In this we have VTH, which is having a 10 volt constant, and RTH is the source internal resistance, RL is the load resistance, IL is the current which is calculated depends upon all these three parameters, and power is also calculated using VTH, RTH, RL and IL. Now this is the amount of power dissipated by the load, or this is the amount of power delivered by the source. Now we will consider that the source internal resistance is 5 ohm, and we will see the graph. The graph in the x-axis load resistance is derived, and in y-axis power is derived. When load resistance is when the source internal resistance is 5 ohm, we will see the power delivered by the source is increasing until it is reaching to the load resistance value of 5 ohm. After the 5 ohm it will start dropping, and in case to verify it, if you are entering the source internal resistance to 3 ohm, we can see that the the power delivered by the source is increasing until it is reaching to a point of 3 ohm. Thereafter it will start dropping for further increasing in the load resistance. I hope you have understood the maximum power transfer theorem. If you have any doubt, please write it in the comment box. I'll reply. If you like this video, please hit the like button. If you have not subscribed my channel, kindly subscribe it. Thank you so much.